Hey everyone, good morning. My name is Jyoti and I have close to 11 years of experience. Started my journey as an automation engineer. Then for a short period of time, I took up a role of a scrum master to understand how exactly project management happens at a larger scale, and currently working as SRE specialist, wherein my roles and responsibilities are related to enabling application team to adopt our common DevSecOps platform, which consists of tools like cloud-based Jenkins, CDRO, etc. Now, what is this series all about? So, through this series, we want to prepare you for AWS DevOps interview. But my idea is not that you just go through these questions and learn them, by heart them, and then go out for an interview. Rather, my idea is that you learn from these series. See, there could be hundred and thousands of questions which could be available for AWS DevOps, right? And you can't learn all of them. But if you know the concept, then irrespective of the questions which comes in the interview, you'll be able to answer. Okay, so let me quickly share what is the agenda for today's session. This is our first session of the series. Okay, now I already gave you overview of the series, which is like it would be fundamental questions will cover around each area, and then we'll go for a deep dive. Again, in fundamental questions, I'll cover very basic things first, okay? And then, so you can consider this as first 10-15 videos would be around basic questions, right? And then we'll pick each topic and we'll deep dive so that you learn about those topics. And we'll also go for a lot of hands-on. So until and unless you practice certain things, you won't be able to understand, learn, and answer those questions better in the interview. Okay. And today we'll start with some fundamental questions on DevOps, and we'll talk about what you can expect in the next session. Now, as I mentioned, so the fundamental question could be around why DevOps, and then some of the AWS services you should know as a DevOps engineer. Then we'll talk about build tool. Majorly, I'll be talking about Maven because I have experience of Maven. Then source code management tool. It could be GitLab, it could be Code Commit, it could be GitHub. Then CI tool like Jenkins, or if we go at the enterprise level, you have cloud-based Jenkins. Then there are other tools as well. So I'll share what I know. Again, see, there could be hundreds and thousands of tools which a company could be using, right? So I'll share what I know, but the core concept of each tool is same. So if you understand the core concept, you'll be able to work on any other tools as well. Okay, and then we'll talk about configuration management tools. Yeah. I'll see if time permits. We'll also talk about Terraform and all. Yeah. Now, in the deep dive sessions, our focus would be to deploy an application using AWS services, which consist of your code commit, code build, or pipelines, and use other services as well, like simple notification service, which can help you to verify, okay, when was the build done? Was the build stable? If it was not stable, what action item needs to be taken care of? And then uh, deep dive on each sessions like Git, Jenkins, Nexus, SonarQube, Ansible, Terraform, etc. Now, fundamental questions on DevOps. So, some of the questions which we'll cover today is why DevOps? What is continuous integration? The difference between continuous delivery and deployment. So, expect one question around this area, which is like, okay, difference between continuous delivery and deployment. Then a interviewer could ask you about explain your CI/CD pipeline, wherein you can talk about, okay, what is your source code management tool, how you go from building a tool to a deploying the artifacts, and then a very important question around how do you measure the success of your pipelines. Okay, how do you measure that which application is performing better. So there is this DORA matrices which helps you to measure the performance of your application. Okay, so let's understand first why DevOps. Um, so generally, when people think about DevOps, what comes in their mind is tools, but DevOps is more than tools, right? DevOps is, yes, automation, which would require you to learn some tools, but it also consists of efficiency, right? Collaboration, coordination. So DevOps is a culture in itself where there is a lot of coordination and collaboration. Earlier, what used to happen, you had development team who were who were responsible for working on new feature bug fixes, and there used to be operation teams who were responsible for monitoring of your application or deployment of your application. And since they were monitoring, etc., they had certain SLAs. They had to ensure that there is certain uptime. There is, like, for example, 99.9% uptime for an application. So their focus was mainly on the infrastructure. Yeah. Now, when DevOps people used to handle the code or the artifact to the operation team for the deployment, uh, since there was no coordination and collaboration between these two teams, they were working in silos. The development team, they used to share, okay, what is it that one needs to do, okay, kind of a readme file wherein steps were written, like this is how you deploy. Now, since you know, when you tend to perform anything manually, whenever there is a human intervention, you are bound to make mistakes. Second, there were limited people who were responsible for deployment. Okay, there were multiple teams working on developing the feature, but the people who were doing the deployment, they were limited. Plus, they had additional tasks, which is to ensure the uptime of the servers, etc. Okay, so whenever there is to so even developers, they had to book a dedicated time, a slot with the operation team for the deployment. Okay, you would have heard about release calendar, etc., right? So wherein they were, so from inception of the idea of the requirement to the delivery, it used to take 3 months, 6 months, because everything had to be coordinated between the operation team. There were limited slot. Okay, the team had to work on patching their servers, etc. So what DevOps does is it helps you in the rapid releases with stable system. Okay, so the KRAs of both the teams are met. The development team had to have to ensure there is a rapid release. The cycle time is less. Okay, from the idea which is generated to whole execution of the that idea, and finally deployment. It should be done in a shorter possible time. Okay, uh, and operation team had to ensure that they have a stable system. So both these teams, they have to work together for each other's KRA. Yeah. So why DevOps? If you have to answer in short, so DevOps is automation and efficiency, or you can say DevOps helps you in rapid releases with stable system. Okay, and in DevOps culture, your development team, your operations team, your security quality assurance team, which is like your testing teams, are tightly integrated, right? Because if you want to automate anything, you have to ensure that, okay, the test cases which are written, they are like they are not giving you false failure. You have to ensure security of the application, everything. So ideally, what used to happen, there was a lot of manual intervention. Okay, there would be a different environment where your artifacts move, right, from your testing environment to a pre-prod to a prod. And imagine if everything is manual. Yeah, how much time it would take to deploy the artifacts from one region to another region. Yeah. uh, Now what people did, they've automated this. Now automation could be of your configuration, automation could be of your application. So for that thing, you need your testing team who helps you in automating your application scenarios. Okay, so if I have to sum up, What are the benefits of DevOps? Then speed, rapid delivery, reliability, and collaboration. Okay, so there is a lot of collaboration and coordination between all these teams. Yeah. Okay. Now, what is continuous integration? Um, I have to take you a little. I have to move little ahead here. So there would be a central repository where developers would be merging their code. Okay. Now, suppose if there was no continuous integration, what would happen? Yeah. This is your main branch, which is your master or a main branch. Okay. There are 10 developers who are simultaneously working on 10 features. Okay. The developer A merged its changes in month of Jan. Okay. Now, there was some developer who went ahead and merged their changes in month of March, and both the changes which were merged in January and the changes which are being merged in March, they have a conflict. Okay. Meanwhile, this developer who had merged the changes in January, he has moved to another project. He has started working on some different project. Now, when research was done, it was found that okay, there is a conflict with something which was merged in Jan. Now you'll backtrack. Okay, Jan, who did? Okay, you have to ask that person to recheck. So, since he has already done his part and moved to another project, it would take some time for him to understand the conflicts and then resolve it. So, what happened here? You're losing time. Yeah. So, with continuous integration, what would happen is yes, there would be a regular merge to the code. Yeah. See, you won't wait for weeks and months to merge whatever you were working to a main branch. But what you'll do is every day, whatever you've done, you have to ensure that yes, it's logically complete and you have to merge it to the main branch. That's why if I talk about Scrum, and when you guys get user stories to work on, it is said try to make it as modular as possible, right? So the story or the work you are doing, it should be such that it should be in a state that it could be merged on a within a day, right? Kind of a best practice you can have. So now with continuous integration, what you are doing is there is a continuous or a regular merge of the code, right? But the you don't leave things just there. The moment the code are merged, what would happen? There would be a build and the automated tests are run. Okay. So with that, if there would be any conflict or any issue, you'll see a quick feedback. Okay, right? And this is only for the develop branch, right? It's not like, okay, somebody created a feature V2 and they are merging it to the main branch. There would always be a intermediary branch, which you can call it as a develop branch, release branch, whatever it is. Okay. So what you're doing is you're continuously merging your code to the central repository. And once it is merged, you build it and you run your automated test cases over it. Okay. These automated cases could be of two kind. One is your unit test cases, right, which is written by developers, and another could be your smoke test or sanity test cases. So when we say smoke test, this could be high level build verification test case which your testers have written to validate that the key functionality of the application is working fine in your lower region when this branch is merged. Similar kind of a smoke test you can have for the changes when it is merged from your develop branch to a master branch. Okay. So now, another important questions which you can get could be around what is the difference between continuous delivery and continuous deployment. Okay, so when we talk about continuous delivery, in previous slides, I was mentioning about the develop branch. Okay, you are merging, you cut the branch from the main branch, you worked, you wrote the code, and then you merge the changes here in the intermediary branch. And after that your build was done and automated test cases were run. So if there is any issue, you'll get a feedback quickly right? And then again, you can create another branch or pull the same branch and do the fixes. Okay. Why we are not merging into the main directly, like, okay, this is the main branch V2, and then you merge directly to V1, because there has to be a lot of test cases which needs to be run, and it's not just about checking the changes with respect to this feature. You want to do whole regression test cases. Yeah. So for that, there are different regions. And In anything which goes to production, there has to be like monitoring, observability is involved, right? Now let's come to continuous delivery. So what happens in continuous delivery? You plan, which is like, okay, you create a Jira ticket, or your product owner, they'll create a Jira ticket, they'll give you the requirement, right? Once that's done, you are going to code. Yeah. Once the coding is done, as I told you, the changes would be merged to your central repository. The build would happen. Once the build is done, the changes are deployed to a lower environment. Okay, from a lower environment, it can go to a test environment if a company manages different environment for, okay, merging the changes of the developer to one environment, ensuring that, okay, they have good test coverage and basic test cases are working fine. Then either they can deploy their changes to a different environment which is just dedicated to a tester. So the best practice is, yes, your developer's environment and your tester's environment should be different, because developer, while debugging, they might create some data, right, in the environment which would be corrupt, or which might not be valid. So it is best practice is, okay, you have two separate environment. Okay, you have your environment specifically for developers so that they can do their R&D, research, debug, and for tester there is a dedicated environment where they can, like, beforehand create their data set, etc. So the moment these changes are deployed to a test environment, now testers, they'll run the automated test cases, or they'll run their end-to-end test cases to ensure, yes, as a whole this application is stable, the feature is also working fine, and there is no regression impact of this changes. Now once the automated tests are run, the result is sent to, say, a release manager or delivery manager, or say a quality engineering manager. Okay, they'll say, yes, there is no false failure if you have a good percentage of test cases which are passing. So if he or she feels, yes, this is a stable build and we are ready to go ahead with deployment on production, the person would approve uh, the notification which has gone to him with the automated test cases. Once that approval is done, you'll deploy to production. Okay. So in continuous delivery, there is a manual intervention. By manual intervention, I mean there would be some kind of a manual approval. Yeah. And all these things can be set up in Jenkins, etc. Right. So in continuous delivery, from planning to deployment to a production, there's one manual step, which is like verification of your test results, of stability of your application until a environment just before prod, which could be pre-prod or alpha, whatever you call it. Okay. So once manual approval is done, your codes, your changes are deployed to production. Now, what is continuous deployment? Same steps, everything is same, except even this part is auto, right? There is no manual intervention. So as I told you, to have continuous deployment, it's very important that you have a check at every point. So you have to have automate your test cases, unit coverage, security, performance. So there has to be a lot of focus on the automation. Yeah, not just the automation of whole pipeline, okay, from build to deployment, but the test cases, the scenario, the end-to-end test cases, integration testing, security testing, performance testing. So the more these pack are strong, you'll be able to release your changes to production without manual intervention, and there would be a rapid releases. Another question which you can be asked is, explain your CI/CD pipeline. Okay, so while mentioning your CI/CD pipeline, talk about your what is the source code management tool you are using. Okay, what is your branching strategy, that is also important, right? Here, as in the previous slide I was telling you, okay, you've got main branch, then you've got your feature branch, then you've got a develop branch, right? So in while mentioning about your source code management tool, do talk about, okay, how developers they do make changes to the existing code. Okay, what is the path or branching strategy for managing your bug fixes for new features or enhancement, etc. Okay, so what is your source code management and the strategy it is followed to take care of new enhancement bug fixes. Then build. Okay, now the as I was telling you, the build tool could be a Maven, Gradle, MS Build, etc. So tell, okay, which build tool you are working on. Then, okay, once the build is done, for do you have anything for code coverage? If yes, okay, specify the tool. Okay, is it SonarQube, Jekyll, or something else? Now, after the code coverage, you've measured the code coverage, right? Now, the artifacts which get generated, where exactly those artifacts are? Are you putting the artifact on cloud or on Docker Hub, or there is a Nexus repository, right? So specify what happens to the artifact. Now, from artifact, how the artifacts are picked and they are deployed, and where the deployment happened. Is it happening on prem or on cloud? Okay. And if you are using to do this, like if there is a seamless flow, you have a Jenkins, which is a CI tool. So the moment, okay, developers check-ins their code to say feature branch, okay, you've created a webhook between your source code management and Jenkins. Okay, so Jenkins polls your source code management tool and sees, oh, there is a change. Okay, once it captures the change, it does the build. Once the build are done, it runs the automated test cases, it scans the code coverage, etc. So you can specify all those things, right? Pick Jenkins, which is like your CI tool, and tell how you've integrated, what are the plugins you have used to integrate with your source code management tool, with your build tools, with your code coverage. So the more you explain about the plugins, the strategies, the branching strategies, the quality checks which you have kept in place, it would give an interviewer an idea that he or she has not just studied about these things, but actually implemented, right? Another thing, when we talk about CI/CD pipeline, right? The current thing which I'm experiencing in my job is, see, there could be a multiple application team, and those application team they can use their pipeline. Like I see somebody is using GitLab Runner, somebody is using what do you say, your Jenkins, right? So in that case, as a DevOps engineer, you should come up with something wherein people are using common pipeline, right? Because then you are diluting your concept wherein you wanted a rapid releases and stable environment. See, if everybody starts using their pipeline, it would be very difficult for other person to help you out in case of any issue. But if there is any central platform, if you have a central platform for CI/CD and all the teams are using common pipeline, it would be easier for us, for a DevOps engineer, to bring changes to those pipeline. But if every application team decide that they'll go for their own pipeline, then it would be very difficult to manage these pipeline. Yeah. So yes, coming back to a question, when you are explaining about CI/CD pipeline, mention each detail from your source code management tool to the deployment. And again, deployment, is it on prem, on cloud? If cloud, what is it? AWS, or it is GCP or Azure? Okay. So yes, we've created an awesome pipeline. People are the application team or development team. They are using those pipeline. But how do you measure that was the pipeline which was created, the automations you did, the automation of the deployment or of the application? Is it really helping you or business for quicker delivery or to go to the market quickly? So for that, there is a DORA matrix which helps you to measure software development and delivery performance. And from where these data comes, so the tools which you're using, right? A source code management tool, for example, if you're using that tool, so you can capture, okay, how many commit was done to that source code management, or if you're using Jenkins, how many builds are done, how stable those builds are, right? So there are some three, four matrices which you can monitor. For example, lead time for change. How long does it take for a code commit to make it to a production? That whole cycle, okay, from plan to deployment, right? How much time it takes. So your source could be your like from where you can get this data is from Jira, right? Your project management tool, like when that Jira was created and when then that was moved to done. Okay, deployment frequency. How often do you deploy to the code to the production? Okay, is it like very frequent, or you're doing deployment in 3 to 6 months? Okay, now what you have to do as a DevOps engineer, if you see that okay, the deployment frequency is larger, like it takes 3 to 6 months for a team to deploy. Now you need to go and collaborate with the development team to understand why there is like why you are having just two deployment in a year or a four deployment in a year. There you might get to know that okay, there are a lot of checks which they are doing is manual. Okay, when they are going from a development environment, things are working fine, but moment they move to a testing environment, the things to starts to break. So here you see that there has to be a collaboration between a developer and tester. Maybe developers they don't know which scenarios they have to test, right? What are the key scenarios which would ensure that okay, the builds are stable. It's not just the unit test coverage you have to check, but there are certain key smoke tests you should run in the development environment before giving it to a tester. Okay, so then the process also comes in our DevOps. Right? So here, like, okay, there would be a process wherein you can say, okay, a developer would hand over the build to tester only when these test cases have passed or when they have run these things, right? And see, in this, you are tester is collaborating with the developer, informing about the test scenarios, and developers they are talking to your testers and explaining them about what are the key features of this particular application. So, as a DevOps engineer, uh, you are helping in collaborating these two teams, right? So, you have to uh, take a deeper look at these matrices. Okay, change fail rate, percentage of changes that result in degraded service requiring hotfix, patches, and rollback. Okay, so this is also very important thing. Now, there are times what happens when the changes are deployed to production. There would be teams who would be involved in monitoring, right? So even that part you have to automate. Okay, that moment there is any bug which is encountered with this changes the deployment, there is alert sent, right? So people use tools like Dynatrace, etc., right? Splunk, Dynatrace, you can create your dashboards, you can create your alert, right? So understand, when we talk about DevOps, it's not just limited to deploying your changes and then you are done. Okay, it's overall. Okay, you have to observe these things. Okay, what is lead time, what is deployment frequency, oh, the change fail rate, the changes which are done by this team, it requires a lot of hot fixes or patches and rollback. So you can collaborate with the stakeholder, or you can be enabler to coordinate those discussion and understand what is the result. Okay, why the changes which are done by this team leads to degradation of services. Okay, why these things are not being caught in the lower environment, or the environment which is given to a tester is not that at par with the production team. Okay, can we go for a process of automating the infrastructure creation and give a template to a tester? Using that template, they can create an environment very similar to production, but since everything comes with a cost, once they are done with their testing, they are also able to delete that environment. Okay. Time to restore the services. How long does it take to restore service after incidents? See, the time will take less if there is a good coordination and collaboration. If DevOps team is aware of what was how this application, this change have been performing, right, in a lower environment, in a higher environment, or before, just before the deployment, there was some meeting done between the DevOps security team, support team, monitoring team, and things were highlighted. Okay, with this changes, we are making so and so change, right? Now, what next? So here I just shared a couple of questions around like, okay, what is continuous integration? Why DevOps, continuous delivery, deployment? How do you explain your pipeline? How do you measure the effectiveness of the pipeline? Yeah. In next session, we'll cover some of the fundamental questions on AWS. Again, when we talk about AWS, there are like 200 plus services, but we are not going to talk about those 200 services, rather the services which you should know as a DevOps engineer. Okay. Yeah. So, yeah, thank you everyone. See you in the next session.